Hi everyone, myself Vanita Gaikwad. I am from Swami Vivekananda School, Hukkeri. Now whole world is suffering from COVID-19. All are at home. So now we are ready to bring online live classes for you. Today we are taking 10th CBSE first chapter, that is real numbers. We'll continue that real number. See the concept. I will write chapter name real numbers. Real numbers. See, before starting this real number, we will discuss basic. See, types of numbers. Types of numbers you already learnt in previous class. In that first one is natural number. Natural number means which starts from 1, 2, 3, 4 and so on. These are the natural numbers. Smallest natural number is 1. Next one is whole numbers. Next one is whole numbers. Whole numbers start from 0, 1, 2, 3, 4 and so on. Whole numbers start from 0, 1, 2, 3, 4 and so on. Smallest whole number is 0. Third one is integers. Here integers 0, 1, 2, 3, minus 1, minus 2, minus 3. Here positive integers are there, negative integers are there. These are the integers. Next one is rational numbers. Rational numbers. Rational numbers, it is in the form of P by Q. Rational numbers, it is in the form of P by Q, but Q is not equal to 0. Rational numbers is in the form of P by Q, but Q is not equal to 0. Examples: 1 by 2, this is rational number. 3 by 5, this is rational number. 7 by 9, this is rational numbers. Next one is irrational numbers. Next number is irrational numbers. Irrational numbers, it is not in the form of P by Q and Q is not equal to 0. Irrational numbers is not in the form of P by Q and Q is not equal to 0. Then how is this number? Which numbers these are? These are root 3, root 5. These are the irrational numbers. You know already even numbers, even, odd, prime, composite. These also types of numbers: even numbers, odd numbers, prime numbers, composite numbers. What we learnt now? Types of numbers in that: natural numbers, whole numbers, integers, rational numbers, irrational numbers and even, odd, prime, composite. Now our chapter is real numbers. Which are these numbers? We'll see now. See, real numbers which are rational and irrational numbers are real numbers. Rational and irrational numbers are real numbers. Next, in this chapter we are going to learn Euclid's division algorithm. Euclid's division algorithm. See, Euclid. Who is this Euclid? Euclid is a mathematician who is a father of geometry. Division means division process, you know. One example I will take here. This is division. Algorithm means procedure. How we divide this? This is one procedure. Algorithm is procedure. Here one more word will come, that is lemma. Lemma. Lemma is a proven statement which we used for proving another statement. Lemma is a already proven statement that we used to prove another one statement. We now know algorithm means what, lemma means what. Now Euclid given one statement, we'll see that A is equal to D into Q plus R. A is equal to D into Q plus R. R is equal to 0 or greater than 0 but less than D. See, how is this? I will say, I will take one example, that is, see, what we call this? Divisor. What we call this? Dividend. What we call this? Quotient. And what we call this one? Remainder. See, what Euclid said? A is equal to D into Q plus R, but R is equal to 0 or greater than 0 and less than this divisor. See, divisor, remainder always less than this divisor. Our remainder is less than this divisor? Yes. Next, we will solve one example on this using Euclid's division algorithm. SCF of this 1656 and 4025. Solution. See, here greatest number. Which one is greatest number? 4025. These given numbers 1656 and 4025 are the given numbers. Which is greatest number is 4025. You have to take that 4025 as a dividend and 1656 as a divisor. One simple method I will say how to find SCF using Euclid's division algorithm. See, we have to divide here. 16. First take this 16. 16 into 2, 32. 16 into 2 is a 32. 16 into 3, 48. 48 is greater than this 40. So I will take 2. See, multiply by 2. 2 6 are 12. 2 5 are 10 plus this one 11. Again 1 here. 2 6 are 12. 12 plus 1 13. Again 1 is here. 2 into 1 2. 2 plus 1 3. In division which symbol will come here? Subtraction. In multiplication what we did? Addition. In division, subtraction. See, subtract now. 5 minus 2 is a 3. 2 minus 1, 1. Now 0 minus 3 we can't, so we have to take it as a 10 and this one is a 3. 10 minus 3 as a 7. 3 minus 3, 0. Is this equal to 0? No. So one more time we have to divide. How? This remainder you have to consider as a divisor. This remainder you have to consider as a divisor. Then this first divisor you have to take first divisor as a dividend. See what I did here? This remainder you have to consider as a divisor and this first divisor you have to consider as a dividend. Now let's divide. See now, first 7 into 2. 7 into 2, 14. See, we can take here 14. 7 into 3, see, 21. 21 is greater than this 16. We divide. This 2. Now 2 into 3, 6. 2 into 1, 2. 2 into 7, 14. With symbol? Subtraction. Now 6 minus 6, 0. 5 minus 2, 3. 6 minus 4, 2. 1 minus 1, 0. Again see here, our remainder is 0? No. Again we have to consider this remainder as a divisor. This remainder we have to consider as a divisor, and this second divisor you have to take as a dividend. This see, take this here, dividend. Next again divide. See, 2 into 2, 4. This 4 is less than this 7. Only this 2 I am considering here. Again 2 into 3, 6. 6 is less than this 7. So 2 into 4, 8. 8 is greater than this 7. We will see, take here 3. We'll solve examples on Euclid's division algorithm. Using Euclid's division algorithm, we'll solve the problems. Find the example is find the HCF of 1656 and 4025 by using Euclid's division algorithm. Solution. See, which one is greatest number here? 4025. 4025 we have to consider as a dividend, and 1656, this one we have to consider as a divisor. Now divide 1656. In that first two terms I will consider here. See, 16 into 16 into 2 is 32. 32 is less than this 40. So 16 into 3 is 48. Yes, is it 48? Yes, this is 48. Is this greater than this 40? See, we want less than this 40, so I will take here 2. Now multiply 2 into 6, 12. 1, I will write this side. 2 5s are 10. 10 plus this one, 11. 1, again this one. 2 6 are 12. 12 plus 1, 13. Again 1 here. 2 1s are 2. 2 plus 1, 3. We multiply. Now in division we will subtract here. In multiplication we add. 5 minus 2, 3. 2 minus 1, 1. 0 minus 3, we can subtract 0 minus 3? Can't. So take the 1 from this. This is become 3 and this will become 10. 10 minus 3, 7. 3 minus 3 is a 0. Is this 713 is equal to 0? No. Again we have to consider this 713 as a divisor. 713 as a divisor, and this first divisor 1656, this one we have to consider as a dividend. So write down here 1656. Take this first number. 7 into 2 is 14 and 7 into 3 is 21. 21 is greater than this 16. I will take this. You can solve this. See, 2. 2 into 3 is 6. 2 into 1 is 2. 2 7s are 14. Subtraction. 6 minus 6, 0. 5 minus 2, 3. 6 minus 4, 2. 1 minus 1, 0. Is it equal to 0? No. Again we have to consider this remainder as a divisor and this divisor as a dividend. Next, divide now. I will take 3 here. 3 into 0, 0. 3 into 3, 9. 3 into 2, 6. Subtraction. 3 minus 0 is 3 as it is. This will become 6. We want here 11, so I took 1 from here. 11 minus 9 is 2. 6 minus 6 is 0. Is it equal to 0? No. One more time we have to divide. Consider this remainder as a divisor. Take this divisor as a dividend. That is 230. See, 230. 23 tens are 230. Yes, 10. 23 tens are 230. 0 minus 0, 0, 0, 0. Now this is equal to 0. Remainder is 0. Now we have to write HCF. Hence, this HCF of 16564025 is, which HCF we have to take here? Where our remainder is 0, wherever this remainder is 0, that first divisor you have to consider as a HCF. Where our remainder is 0, that first divisor you have to consider as a HCF. This is our HCF of 1656 and 4025. HCF is 23. Let's see one more example using Euclid's division algorithm. Next example. I will write here next example. Find the HCF of, only numbers only I will rub here. Find the HCF of 135 and 225. Find the HCF of 135 and 225 by using Euclid's division algorithm. Now solution. How we solved in first example? See, which number is greater here? 2 to 5. This consider 2 to 5 as a dividend. 2 to 5. Next, 135 as a divisor. See, 135 1 135. See, if we take 135 into 2, what will get? 270. This is greater than this 225. So I will take here 135 1 135. See now, subtraction. 5 minus 5 is 0. 2 minus 3, we can't. So take 1 from here. That is, it will become 12. 12 minus 3 is 9. 1 minus 1 is 0. Next, is it equal to 0? Remainder is 0? No. Again we have to divide this. Consider this remainder as a divisor and this first divisor as a dividend. This 135. Next, 90 into 2. 2 into 0, 2 9s are. So I will take here again 1 only. 90 1s are 9. See, again subtraction. 5 minus 0, we can't subtract 0, so 5. See, this 13 minus 9 is a 4. 13 minus 9 is a 4. Is it equal to 0? No. Then again we have to divide. We have to consider this remainder as a divisor. First divisor you have to take here as a dividend. 90. So 45 to the 90. 45 to the 90. So 0 0. See here, our remainder is 0. Now HCF, therefore hence HCF of 135 225 is, which HCF we have to take here? Where our remainder is 0, that first divisor we have to take as a HCF. Our HCF is 45. What we did here? We divide 135 by 225 divided by 135. 135 ones are 135. We subtracted, we get 90. Again we consider this 90 as a divisor and 135 as a dividend. So 90 ones are 90, will get 45. So again this is 45 is not equal to 0. So again we consider this 45 as a divisor, again this 90 as a dividend. So 45 twos are 90. So 90 minus 90 is 0. We got remainder as a 0. So we have to consider where our 0 will come. That first divisor you have to take as a HCF. So HCF of 135 and 225 is 45. Next one example. We'll see using Euclid's division algorithm, that is show that any positive even integers can be written in the form of 6q plus 2 and 6q plus 4, where q is an integer, See, we have to show that these even integers can be written in the form of 6q plus 2, 6q plus 4, where q is an integer. Now solution. See, look here, Euclid's division algorithm. What said Euclid? Let's apply Euclid's division algorithm. See, what said Euclid? A is equal to D into Q plus R. Here D is equal to 6, given that D is equal to 6, given that. Now put R is equal to 0. If R is equal to 0, then A is equal to D is 6q plus R is 0. We'll get A is equal to 6q. We'll take here 2 outside, inside the bracket 3q. Inside the bracket 3q. See now, look here. If you take q is equal to 1, see, A is equal to 2 into bracket 3 into 1 is 3. 2 into 3 is a 6. See, if we take q is equal to 2, next see, A is equal to 2 into bracket 3 into 2. See, 6 into 2 is a 12. See, q is an, when we take 1 we'll get 6, when we took 2 we get 12. See, when even number multiply by any number we'll get the even number. So is an even number. Q is an, see, it's an even number. This 6q is an even number. How this even number? I said now. See, if R is equal to 1, A is equal to 6q as it is, R is equal to 1. Now we can't take outside common, so now put here q is equal to 1. Now A is equal to 6 into 1 plus 1. We'll get 6 plus 1 is 7. If q is equal to 2, see, A is equal to 6 into q is 2 plus 1. 12 plus 1, 13. Next, q is equal to 3. We'll get 6 into 3 plus 1, that is 18 plus 1 is 19. Which these numbers are even numbers? No, these are odd numbers. Now A is equal to 6q plus 1 is a odd numbers. Is an odd numbers. 6q is an even number. 6q plus 1 is an odd numbers. See, if r is equal to 2, if r is equal to 2, a is equal to 6q plus 2. Now we can take 2 common here. A is equal to 2 common. If we take, then 3q plus 1. See, here if we take q is equal to 1, then a is equal to 2 into 3 into 1 plus 1. What? 2, 3 into 1, 3 plus 1. So 2 into 4. 2 into 4, 8. We got even number. Next, q is equal to 2. A is equal to 2 into bracket 3 into 2 plus 1. So 6 plus 1. So 2 into 7, that is 14. We got even number. So is an even number. Is an even number. Next one. We got 1 odd number, 2 even numbers. Next, if r is equal to 3, see, a is equal to 6q plus 3. If r is equal to 3, a is equal to 6q plus 3. See, we can take common 3. A is equal to 3 into bracket 2q plus 1. If you take 3 common, inside the bracket 2q plus 1. If you multiply by 3, we'll get same here. See, apply here. Q is equal to 1. That is 3. A is equal to 3 into bracket. Q is equal to 1. So 2 into 1 plus 1. 3. Inside the bracket 2 into 1 is a 2 plus 1. So 3. 3 into 3, 9. Next, if q is equal to 2, a is equal to 3 into 2 into 2 plus 1. So 3. 2 into 2, 4 plus 1. So 3 into 4 plus 1 is a 5. 3 into 5, 15. Which number these are? Odd numbers. So is an odd numbers. Write down in front of the odd numbers. Is an odd number. Is an odd number. Next, if r is equal to 4, a is equal to 6q plus 4. We can take 2 as a common. A is equal to 2 inside the bracket. 2 3s are 6 plus 2. Now apply here. Q is equal to 1. If you put q is equal to 1, we'll get, directly I will write here, 3 into 1, 3, 3 plus 2, 5. 2 into 5 is 10. 10 is a even number. Next, if q is equal to 2, a is equal to 2 into 3 into 2, 6. 6 plus 2, 8. 8 into 2, 16. If q is equal to 3, see here, a is equal to 2 into bracket 3 into 3, 9. 9 plus 2, 11. 11 into 2 is 22. Even numbers. Is an even numbers. Is an even number. So what was the question? Show that any positive even integers can be written in the form of 6q, 6q plus 2, 6q plus 4. So we can write, see, 6q is an even, 6q plus 2 is an even, 6q plus 4 is an even. So hence we can write any positive even integer can be written in the form of, hence any positive integers can be written positive even integers. These are even integers can be written in the form of 6q, 6q plus 2 and 6q plus 4. We show that any positive even integers can be written in the form of 6q, 6q plus 2 and 6q plus 4. Once again I will explain, see how to write this. First we have to apply, let's apply Euclid's division algorithm. Euclid said that A is equal to dq plus r. Here d is equal to 6 given that. So if we put r is equal to 0, we will get A is equal to 6q plus 0 or A is equal to 6q. If we took 2 common, inside the bracket 3q. If we apply q is equal to 1, we will get here 6. If we apply q is equal to, if you put q is equal to 2, you will get 12. So 6, 12, these are even numbers. So is an even numbers. If r is equal to 1, so A is equal to 6q plus 1. So if we take q is equal to 1, we will get here odd numbers. So we wrote here is an odd numbers. If you wrote r is equal to 2, we will get here even numbers. If we take r is equal to 3, we will get here odd numbers. So hence any positive integers can be written in the form of 6q and 6q plus 2, 6q plus 4. And any positive odd integers, see here, any positive odd integers also can be written in the form of 6q plus 1, 6q plus 3.
We'll end up with this today. In next class, we'll see next point of this real number chapter, that is fundamental theorem of arithmetic. Stay home, stay safe. We'll meet you in next class.